Students, today I am going to discuss the fourth case of sensitivity analysis. In this case, addition of a new variable is discussed. That means we want to add another variable. For example, if the problem is of two variable problem, then we are adding third variable, fourth variable, and so on. So it may happen that by formulating the model, an important activity is ignored. जब आप मॉडल कर रहे होंगे प्रॉब्लम को, तो आप किसी एक्टिविटी को आपने हो सकता है छोड़ दिया हो. So now it is introduced in the model through a new variable. So now you want to introduce that activity with the help of a variable. Such a variable shall be considered as a non-basic variable. So now this new variable is considered as a non-basic variable. Fine. In the optimal table. क्योंकि आपने एक प्रॉब्लम ली, उसको सॉल्व किया, अब आप उसको ऐड कर रहे हो, तो जो वो प्रॉब्लम आपने सॉल्व की थी उसकी जो ऑप्टिमम टेबल होगी उसमें आप नए वेरिएबल को एज ए नॉन बेसिक वेरिएबल ट्रीट करेंगे. फाइन. वी शैल नॉट टेक इट कोएफिशिएंट इन द कॉलम इंक्लूडिंग जीरो रो टू बी चेंजेस फ्रॉम जीरो टू न्यू वैल्यूज एंड देन प्रोसीड एज केस 2 and 3. So we will discuss this with the example how to deal with this. So let us see the case. This is an example. This is the problem. This is the problem. Or two variable 3x1 plus 5x2. x1 is less than equal to 4. 2x2 is less than equal to 12. 3x1 plus 2x2 is less than equal to 18. Fine. So now first construct the initial table. Initial table of this, which is this problem we have already discussed in previous lectures. So here is the initial table. This is the initial table. The initial table of this problem is this. This is the identity matrix. After adding surplus variable here x3, x4 and x5, we have this table. Fine. Apply the simplex method and now we get this as the optimum table. This is the optimum table. Final table. Fine. Now a new variable x6 is added because we have already reached x5. So new variable is denoted by x6 here, and new problem becomes 3x1 plus 5x2 plus 7x6. So here we have 3x1 plus 5 plus 7x6 is added here, subjected to x1 plus x6 is less than equals to 4 here, 2x2 plus xt is less than equal to 12 here, plus 3x1 plus 2x2 plus 2x6 is less than equal to 18. So we have added this x6 column actually in the problem. Then so now find the solution, optimum solution. How to solve this problem? So initially you can see that here we are having 0x6, 0x6, 0, 0x6, 0x6. So 0, 0, 0. But now the values are 7, 1, 1 and 2. Fine. So on the basis of this, we have to apply case 2 and 3. So now what is the delta C6? Initially new value is 7 here, coefficient. But here the value is 0. So 7 minus 0 is 7. Now the values in the x6 column will be denoted by a61, a62, a63 corresponding to first constraint, second constraint and third constraint. So now find out the change. Delta a61, delta a62, delta a63 is equals to new. Here the coefficient of x6 in first constraint is 1, coefficient of x6 in second constraint is 1, coefficient of x6 in third constraint is 2. But initially here there is no x6 here, here and here, so 0, 0, 0. That's why 0, 0, 0. So the difference is 1, 1, 2. This is the change. And now apply formula number 3 and 4. What is the formula number 3 and 4? Formula number 3 and 4 is this. Here is the formula number 3 and 4, which we have used in case number 2 and 3. Because here is delta A6. So that's why we have to use 3 and 4. Here is no A6, A6, so that's why there is no need to use these formulae. So now we are using this Formula number 3. So what is your y1, y2, y3? This is your y1 star, y2 star, y3 star. So now substitute these values 0, 3 by 2 and 1. So 0, 3 by 2 and 1. This is the change vector, this change vector in this formula. This is your change vector. So which is 1, 1, 2, 1, 1, 2. Minus delta A C6 is 7. 7. Substitute this value minus 7 by 2. Fine. Now apply the fourth formula. This is the inverse matrix. Multiply by this change vector. So inverse matrix is this. Inverse matrix is this. Multiply by this change vector. So this calculation is done here. S1 S2 inverse matrix multiply by this. That means this is the inverse matrix. This matrix multiply by this 1, 1, 2. So this calculation is done here. So we are getting this matrix, a vector. So now old was 0, this was the old 0, 0, 0 and 0, because initially here is no x6, so 0, 0, 0, 0, 0. So that means we are now writing x6 column here. So initially the values are 0, 0, 0, 0, 0, 0, 0, 0, plus improved the changes are 2 by 3, 1 by 3, 1 by 3. So this is written here, and this is delta Z6 minus C6. So this column is actually this column, and this column is your original column, old plus change. So this is 2 by 3, 1 by 3, 1 by 2, 1 by 3, which is this, and this is from this formula 7 by 2. So now substitute it here. Now take the add. So we are getting this value. Now you have to substitute this value here, because this is your identity matrix corresponding to x3, x4, x5. So now we will insert new variable here rather than here, because this is the identity matrix. So we have to take in the corner. Fine. So here is x6, inclusion of x6 is here. Now you can see that after introducing this x6 variable, here is a minus 7 by 2. That means non-optimal. So now x6 enters the basis. X6 enters the basis because now we are using usual simplex method. So x6 enters the basis. Find the minimum ratio. Minimum ratio is corresponding to this is 3, 12 and 6. 3, 12 and 6. Minimum is 3. So x3 leaves the basis. X3 leaves the basis, and the new variables are x6, x2, x1. Do the calculation. After doing the calculation of simplex method, here we have minus 3 by 2. So now x5 enters the basis, and then find out the minimum ratio. Based on this, x1 leaves the basis. Again do the calculation. So we get this. All the values are positive here. All the values are positive here. That's why optimum and feasible. And this is the solution. Fine. So this is the case. Case number 4. Now we will discuss case number 5 in the next video.